Okay, so today is Java 3 lesson 4, and today we're learning about inheritance. So inheritance is about the passing of attributes from a superclass, which is a generic class usually, to a subclass, which is a class that has more definitive attributes than its super class. So I have like an example of superclass and subclass. So I'll like point things out to you later. So don't worry if this is like confusing. And by attributes, I usually mean like stuff like variables and methods, that kind of stuff. So each class can have any number of subclasses, but a subclass has to have 0 or 1 superclass. So this is how to create a subclass. So notice here that usually superclasses are just regular classes. They become a superclass when you create a subclass that extends the superclass. So that's why, so basically they're all regular classes except that one just like gets attached to another. So that's basically what inheritance is kind of about. So some other information before we get to that like thing. So object and protected. So every class has a superclass except object, which has no superclass. So if a class doesn't extend anything, then by default, object is its superclass. A subclass inherits every method and attribute from a superclass. So if you create a subclass object, then you'll be able to use a superclass method. So I think I mentioned object before, and that's kind of what I mean by here. So since every single class that you create, they're basically subclasses of object. So basically object is kind of like a generic class where you can do different stuff. And by its like you don't have to specifically state that you extend anything, like it kind of extends by default. So every class has attributes of object. And down here, variables and methods that are protected can only be used by the class and its subclasses. So it's programmed using the same way you do with private variables. So just by replacing like the private with a protected, like a public with a protected, that kind of stuff. So the reason why I didn't go over this last class when I went over private and public was because you needed to know about inheritance before you could learn about this. So. Constructor of subclasses. So like I said before, subclasses and superclasses are the same. They're just like they're just classes basically, but they're just one is attached to another. So, but because you're attaching something to another thing, then you need to do something first for it to work. So one of the things we have to add is, so the inside of the constructor has to start with something like called super. So this calls the constructor of its superclass and fulfills the superclass's constructor. In between the parentheses, you put the elements that the superclass constructor needs. You can create an object only for the subclass, which will allow you to use both the subclass and superclass methods. So because the subclass is gonna, you might need to use some of the superclass methods. So to be able to do that, you need to fulfill the constructor. Otherwise, it's not going to work. And the superclass doesn't have the variables it needs to execute anything. So that's why you need to do this. And so what this means is that in the subclass constructor, you might need to pass a few more variables in so that you can fulfill, put those parameters inside this thing so that you can call the superclass constructor. And notice that it has to go in the very first line of the inside of the constructor, the subclass. Otherwise, it's gonna create an error. Casting. So this is also more information about it. So for casting, you can convert class types as well for inheritance. So for example, if we had, if you remember, so if we wanted to create an object of a class, we do the class name, a variable name here, equals new, and then class name here. But notice that I didn't put the same one as this one. So I have an A here and I have a B here. So basically this is saying that create an object that has a type of class A, but the value should be a B object. So a class B object. So this works and everything. So if you run it inside Java, it works as long as you have like the correct implementations of Java in there, like classes. But otherwise this would work and this wouldn't cause an error. So this is kind of like saying that, so you would create an object. Like the main thing about this is that this value here. So if you create, if you put the pass the parameters in, then it'll create a B object basically. And sorry, I need to like gather my thoughts. It'll create a B object, and you can use all the methods of the subclass and the superclass, since if we're assuming that A is a superclass and B is a subclass, then it should be able to do that. And this A here is kind of just like a placeholder in a way, but it doesn't really matter too much. And the only way that you can do this is, since B is a subclass of A, and like B is kind of like A in a way, since you're using the superclass methods as well. That's why you can put it as A. But if you can also put this as B, that would also work, since it's like regular calling an object. But if you wanted to do like B here and then new A, I don't think that's gonna work. I'm not sure yet. I have to test it, but if I'm correct, it can't work. So, but anyways, moving on. So this next line, you can see here that I have B as a type here this time, and then a class name. Oh, well, not class name, but variable name equals B class 1. So basically what this is saying, if you remember how we were experimenting with casting back in Java 2, this is like casting. And so basically what we're saying, that since this has a type of A, we're going to turn the type of it into B. And so if you print it out now, like if we change, sorry, let's just say if we wrote this statement again, it would say B class 1 equals new B. And so basically it just changed the types. Sorry. So this is only allowed because A is a superclass and B is a subclass. So you can't cast from one subclass to another subclass if they aren't related to another. So it's better if I like draw something out, but I don't have like a drawing right now. Maybe I'll draw something later. But class cast exception is an exception that occurs when an object is cast to something that isn't an instance of. So I have like something more explaining about instance of later on. So there will be more information on that. But what it basically means is that if you have like a new A, for example, as a value, you can't, or sorry, for example, if you had a class of C and then that's attached to this like class A, and then it's like as like a subclass. So if A was a superclass and B is a subclass and C is also a subclass, if you had something of type B, for example, well, not type B, I guess, then you can't cast to C because they're not related to each other. Sure, they're related through A, but you still can't cast between them since it doesn't work like that. And in this case, if you think of like the superclass as like the parent and like a subclass as the child, then you can see how like that is related. So like the child is related to the parent, but you can't cast, like, the child and the child aren't, like, it's hard to explain. But yeah, so in that way, it's also similar in the way that you can only have like one superclass, but you can have a lot of children. So instance of. So to stop runtime errors when you're trying to cast from object to object, which is, and to also stop like class cast exception, which was the one I mentioned, you use the instance of operator. So example over here. I need to fix the indenting of that, but it's fine. So if I create, like, just pretend there's like a vehicle and then there's a truck. So the vehicle is the superclass and the truck is the subclass. And so if we create something like this and then do if v, which is this, instance of car, and then car c equals car b, then or else just print that the vehicle is not a car. So basically, just pretend that car is a subclass of vehicle and the truck and the car are not related. So in this case, we're saying that if V is like related to car, then we create a car here and then we cast it to a car. But else, then we print out the vehicle is not a car. And in this case, it would print out the vehicle is not a car since the truck and the car are not related. So when using this, the left side of the operator should be an object. So an object here. Oh, sorry. I can't determine my right and left apparently. So the left side should be an object, which is here. And the right side should be a class name. So this helps test of casting can occur. And since you can only cast from a superclass to a subclass or from a subclass to a superclass, this helps to make sure that your code won't cause any errors. Overriding methods. So it's also possible to write another version of a method in the superclass. Sorry, that doesn't make sense. To write another version of a method in the superclass in the subclass, which is called overriding a method. So this is where you write the same method from the superclass and subclass again, making some changes to it if need be. Again, it's optional because if you create a subclass object, you can already use superclass methods. So again, it's optional, but sorry. Overriding a method is optional. Like you don't have to override a method in the subclass if you don't need to. But again, so this optional was kind of referring to another thing, but like it's optional, but you can write at override before the method that in the subclass to signify that the superclass method after is being rewritten. So if an object calls the subclass as the value and uses the rewritten method, then it calls the subclass method. But if the object calls the superclass as the value, then it uses the superclass method. I have an example of it here. Okay, and you can see here that first over here, I have a class of vehicle and a class car extends vehicle. So this is the subclass and this is the superclass. Over here, I have a car A. So here equals new car 25 in blue, which is stated here. And note that how over here in the first line of the class car constructor, I have the super. And so I pass in this integer A, even though it's not stated here, but we have to put an integer A here because the vehicle class requires it, right? So that's why we have to put it in the super and why we have to add it in the parameters. So then we just set the color equals B. And then we have here like a generic kind of display method really. So print info, and then we just print out the gas value. But then you can see here that in the car class, I at override and then public void print info, And this time I print out both the gas and the color. So in this case, when we do a.print_info, it prints out 25 blue. And same thing, well, if you change this value to like a vehicle, and then you would have to not put this blue here then, since there's only a gas variable, so you only put that the 25 there. But if you do it then it would just call this method here instead of this method. Also, what I meant by like superclasses being like a generic class is really like, if you think about it here. So the vehicle and the car kind of is a good like analogy of this. So the vehicle is generic, right? Because you can have any type of vehicle. You can have like a bicycle, you can have a truck, you can have a car, you can have a boat. There's a lot of things a vehicle can be, but by this subclass, you're kind of like making what you want more definitive. So a car is more specific, right? There's only a certain amount of cars, like certain type of car you can have, but a car is a type of vehicle. So these two are related, but the car is more specific than the vehicle. And so that's why I said that the superclass is usually very generic, since you have a lot of subclasses, then the superclass should be very easy to extend from, basically. Because if you had a load of variables in like the superclass and then you had to do it all in the subclass and make more variables, then that's not very generic. And so basically keep the superclass generic and not very complicated. And then the subclass should be more specific. So equals and toString. So these are types of like methods. So the object class, which all classes are the subclass of, has a toString method that allows someone to print out an object you create for a class. It has no parameters and prints out a string. It's not required to implement in classes, but you can override it in class. So basically what this means is that, object already has the toString method, but it's not required to implement in classes since it's already there. But you can override it in a class if you wanted the method to print out a specific thing. So the toString method in the objects class is really generic. It doesn't really specify like to your needs. So if you wanted to print out something, it probably won't print out exactly what you want. So that's why people would override it in a class so that it can print out what they want. It's mainly used to convert something to a string and print out a statement. If you implement it and write a print statement with the object name in it, it would use like this means that if you use it in the main method, if you do that, it will use the toString method of the class. It's possible to override the equals method in the class as well. Yeah, so we looked at the equals method last time when we were doing the comparing objects. So again, it's possible to override the equals method in class as well. So by default in object, the method sees if memory addresses are equal because it first checks the equals method first. Well, not equals operator. But by overriding it, you can make it compare values instead, which is important since otherwise it wouldn't work properly. So we talked about how in like strings, it just does like compares value like it should. But in object, which classes are all subclasses of, then when you're using it without overriding it first, it just first checks the equals. So that's why it will compare memory addresses instead of actually values. So that's the reason why you have to override it. Examples. This is like examples of how you might write each of these methods. So you can see here that I can have a method public boolean equals object O. And so again, since object is like a superclass of all classes, then you can also use that as a type. So that's why you can write object O. So you can return this equals O. So this basically, by saying this, you're basically saying, oh, is this value equal to the object that you pass in, that is. And this toString here, you're basically, yeah, so public string equals, oh, that actually should be toString, sorry. You need to change this, but it should be public string toString. And then remember here that there's no parameter, so you don't pass in anything. And then return variable 1 and then variable 2. So this var1 and var2 are basically just your instance variables in the class. So just returning these two with a string, of course. And yeah, that is it for this lesson then. There's a lot of things I need to change, but I'll change them soon. Otherwise, in a few seconds, I'll be putting up the class problems. Okay, so this is the class problems for today. Just make sure that you're practicing it, since I understand that's a little bit confusing and complicated. So make sure that you're reviewing the video or the lesson slides again, just so that you're familiar with it, and to practice these problems so that you're also confident on your skills. Otherwise, that's about it. So if you have any questions, comments, or concerns, you can put them in the comments below. But otherwise, that would be it for this lesson then.